Okay, hello and welcome back. Thank you for joining today. Today is day 3 and we'll be starting in the next minute or so. I'm just waiting to see who all is joining us and we'll get started pretty soon. So today's day 3 of the AWS Cloud and AI Essentials, where we were introducing you to some core concepts and some core fundamental training and foundational training on the AWS platform, looking at what cloud computing is, some of its core services, and also obviously taking a look at some AI services, which actually we'll be looking at tomorrow. Today's focus is going to be on compute services on AWS. So if you've been joining us so far over the last 3 days, then obviously this is going to be absolutely fantastic for you. I'm just looking at a question. If you've missed the last 2 classes because you found these classes just today, no problem. We've recorded everything on our YouTube channel. And in fact, if you give me 1 second, I will, let me just help you out here. So I will drop in the chat the link to our YouTube playlist that you can then take a look at the previous recording. So just give me 1 second, I'll get the playlist for you, and that will help you stay on track. Okay, so here we go. Playlist. Okay, shareable link. So I'm just putting the playlist in the chat. To playlist for this week. Okay, let's just put that in the chat for you. Shareable link. Okay, so that's the playlist that's in the chat. And then obviously, if you've missed any of the sessions, you can review the recordings and that will hopefully help you out. Okay, all right, let's get started. Okay. So that is done. Okay, so we'll move on next. Just give me a couple of seconds. Okay, great. Awesome. Okay, so as I said earlier, today we're going to be looking at compute services. And so we'll start off swiftly. Again, this is just to show you that everything is available to you on our YouTube playlist on the YouTube channel as well. The link of which I just literally put in the chat. So hopefully you get that. Before we go any further, I hope you can see my screen. If I can get a thumbs up as a reaction to know that you can see my screen, that will really help. Awesome. And that I'm audible. So I'm obviously audible because you're giving me thumbs up. That's great. Thank you so much. All right, let's get started then. So we'll do a quick recap first from where we were yesterday, because I think we sort of had lots to cover yesterday in terms of S3 storage and CloudFront. So I thought it's a good idea to do a quick recap, give you an opportunity to just see exactly what we achieved yesterday, because what we achieved yesterday is something that we're going to be using on Friday as well. So yesterday, what we did was we explained the fact, or I was explaining the fact that you can use an Amazon S3 bucket, which is an object storage solution, to host a static website. A static website is one that doesn't have any processing capability. It doesn't run any server-side scripting. However, most front-end sites that you look at today, they run standard HTML, CSS, maybe there are some different combinations of those. And then they also may have inbuilt as part of it lots of things like JavaScript, etc. Those scripts run in your browser. They don't actually run on some server somewhere. And so as a result of that, you're able to publish and create a website, a front-end facing website using a standard S3 bucket, which is really brilliant because the cost of hosting that website is drastically reduced, okay? Rather than having a server, you're paying for compute, storage, network. It's very expensive. As when you compare it relatively. With an S3 bucket, you can host a static website, the front end of your website, if you will, and that can be also very scalable because AWS takes care of, ensuring that it can handle almost any amount of traffic that hits that website. So that's really the reason behind using S3 buckets as static website hosting services. Now, yesterday we said that, if you have a global customer base, one of the issues with hosting content in a bucket is that buckets are regional. So if I create this bucket in the United States, a customer in Sydney, depending on what it is they're accessing, if it's a 5 GB video, for instance, there may be some latency issues. Nevertheless, in this use case, it's perhaps not so much of an issue because we're just building a resume website, a website that hosts your resume rather than you sending out, PDF or Word documents to recruiters and hiring managers, etc. So the idea behind this is we can convert this bucket into a static website hosting service, deploy our HTML, our index.html page, our website page on it, and make it publicly available. There were some downsides to doing it this way. Okay, firstly, because the bucket is hosted, on the other side of the planet, there may be some latency issues. And in order to set this up, you would have to configure the bucket with something called static website hosting. Very easy to do. I kind of showed you the steps yesterday. You would have to disable block public access settings. Now, this is something that's a bit of a security concern because even though the permissions that are defined on the bucket is that you can only get objects from it, it's still nevertheless a security concern for a lot of security folks out there. So you have to disable block public access. You have to enable public access. Otherwise, obviously, the bucket cannot be accessible. And therefore, the CV, the resume cannot be accessible. You have to create a bucket policy to allow anonymous access. Again, it makes sense because you want all of the recruiters across the globe to be able to connect to your website and see your resume. That's the whole point. But doing it directly on the bucket itself is a bit of a security concern. There's one issue as well. Currently, as of today anyway, static website hosting is only accessible over standard HTTP access. This is on port 80. And if you notice that sometimes when you're using Google and you go to a website that is only operating on HTTP rather than HTTPS, you'll see that error message pop up, right? This site is not secure. Are you sure you want to continue? And then you got to click the advanced button and say, yeah, continue anyway. So there is that problem there. So you would have to basically have a mechanism, something in front of it to try and encrypt that traffic. The HTTP access basically means that the traffic between our friend over here in Sydney and the bucket is not encrypted. Okay, so that's a concern. The other issue is obviously, as I mentioned earlier, there may be higher latencies over larger distances. And for a single web page with some HTML, maybe not an issue. But if you're trying to access a 5 GB video, then that will definitely present itself a bit slow and lagging and what have you. Okay, so we suggested that instead of doing all of that, we use CloudFront. What CloudFront does is it makes use of those edge locations. And you create something called a distribution. And incidentally, with the distribution, you can either make it globally accessible, or you can make the distribution available in certain areas like the Americas and Europe and then Asia. So you can actually you can actually determine which geolocations you want to make that distribution available in. And there's a difference in cost, obviously, as a result of that. But let's say you create a distribution that's globally accessible. The customer then is going to access your website using what's known as a CloudFront distribution point, which is going to connect to the closest edge location closer to the customer, okay? And using AWS's backbone network, so basically the customer connects from the internet to the local edge location, and then after that, it's on the AWS's network. And that goes through to the CloudFront distribution, hits the web site on your S3 bucket, and obviously he or she can basically access their resume or whoever it is that needs to access the resume. The key benefits of doing it this way is that you can have HTTPS connection. Okay, by default, CloudFront will enforce HTTPS requests. Okay, so it's encrypted. So the traffic between our friend here in Sydney and the bucket, or rather, and the distribution is now encrypted. There's improved security because you can access the website via the CloudFront, what's known as the object access control. Okay, so this is basically what happens here is you do not need to disable block public access setting on the bucket anymore. You will instead create a policy that says the only entity that can access this bucket is this distribution point. And it therefore acts as a proxy for our user in Australia to access that content. So she is going to go through the edge location, hit the actual distribution point, and the distribution point is going to be permitted to connect to the actual website and then proxy across the information back to the customer. This way, we're not disabling the block public access settings. We're not creating a bucket policy that allows anonymous access. So it's a bit better in terms of security. The security postures improve dramatically there. Okay, and it's also got a lot of integrated firewall capabilities. So there's the web application firewall. It integrates with another product called Shield, which helps prevent against distributed denial of service attacks, the kind of attacks that you may have heard about over the last couple of years with various organizations, across the globe. So there's a lot of security enforcement and protection around your website now if you use CloudFront. And so if I briefly take you back to what we were doing yesterday, so just give me a second. And sorry, 1 second, we'll just take you back to the actual web page. Okay, and what I'm going to do very quickly is let me just reshare the screen because I want to show you something interesting. Okay, I'm just going to reshare the screen. Okay, so I'm going to take you to my AWS account. Okay. And what you should be able to now see is we'll just log into my AWS account. Okay. And so yesterday what we did was, let me just quickly take you to the S3 bucket again. Okay. So if you remember, I had created this Rajesh resume site. I'd created this website subfolder, and in that I'd uploaded the index.html page for our user, Jason Coffey. Okay, and in addition to that, we then created this CloudFront distribution point, right? And the CloudFront distribution point had its own URL. So that's the Rajesh resume site distribution point there. And so what I can do now is I can grab that distribution name, open it up in a browser, right? And remember that it's got a folder in there called website is a subfolder. And then in that is the HTML page, right? And so that's going to take me directly to my website. So this now is accessible over the entire planet. Okay, so if I put that in the chat, you can give that a go. You can connect to that and you can see that you should be able to access it as well. So essentially what we've done, we've got an S3 bucket with our web page or web pages. We've got a CloudFront distribution point in front of it. It gives us a CloudFront distribution URL, and then we distribute that URL to our users, our customers, our business partners, whatever we might like. Okay, and so now we can access that service over the internet globally. Okay, so that's how it all works. Let's go back to the slides and let me quickly, let's move on to today's topic today. If you've got any questions so far, do drop it in the chat. Okay, right, I'll just reshare the screen for the slides. Good. Okay, you should be able to see my slides now. So we've completed day one, we've completed day two. Today we're going to move on and talk about compute services. So there are different types of compute services. There's standard virtual machines called EC2. There's ECS, which is containers, and there's Lambda, which is function as a service, or the ability to execute serverless code or code in a serverless environment without you having to manage service. And then we'll also talk about how some of these resources can talk to each other, which is a critical part of any architectural build out that you do. Okay, so introduction to EC2. So Amazon EC2 is basically your ability to rent a computer in AWS's data center. So you get a fully functioning, end-to-end, fully optimized, fully working virtual computer in the cloud. Okay, so you've got your laptop, you know how your laptop works. It's got memory, it's got CPU for processing, it's got storage. In the same way, we can build virtualized versions of that computer, and we call them obviously servers. And in EC2 language, we call them Elastic Compute Cloud, or EC2 for short. Okay, and EC2 in plain English is therefore a virtual computer running in the AWS data center. You choose the operating system, so you can have Windows, you can have Linux, you can even have Mac, and you connect to it over the internet. So you remotely see the desktop using your browser, okay? Or you could use one of those client applications that give you more functionality to connect to that remote desktop. In the case of Linux machines, you usually connect to just a command line interface, a terminal, a shell, as we like to call it. But in Windows, you get full access to the full desktop environment. So it's like the computer was, at your desk. It runs in an AWS availability zone. This is a critical point that I want to highlight here. There are different services from which you create resources like S3 buckets, RDS databases, EC2 instances. Different types of resources run in different global infrastructure environments. In the case of S3, we spoke about it yesterday, that runs in a specific region. So it's available across the region, okay, across the availability zones in that region. In the case of an EC2 instance, a virtual server, it runs in a specific availability zone. And this makes sense because you can have multiple copies of that EC2 instance running the same application across multiple availability zones in the region, so that if one availability zone dies, has a disaster, you can still connect to your application that's running on the other EC2 instances in the other availability zone. So it's like buying a laptop, but instead of sitting at your desk, it lives in an AWS building. You remote over the internet and you use it like your own machine. Install software, run code, host a website, whatever you like. The EC2 service itself, basically the charges are on a per hour, actually on a per second basis. You can stop, start, resize at any time, and you've got full administrative access to it, what we call full root access to it as well. With this, when you look at it from a laptop analogy, you can upgrade it, and that too in minutes. So you can increase the amount of CPU it has, you can increase the amount of memory it has. You can even clone it instantly, so you can create a copy of it, and you only pay for when it's switched on. This is known as the on-demand pricing model. So if you switch on the computer or the virtual machine today at 8 a.m. and then shut it down at 5 p.m., you're only paying for that duration that it's actually in the on state. If you switch it off, it's still available to you. You can bring it up online tomorrow again, and you haven't spent money paying it for overnight. Okay, so in that way, you can see initially the benefits of cloud computing. You're paying as per consumption, kind of like electricity, as we discussed on day one. Let's take a look at how it actually works. So when it comes to EC2 instances, as I mentioned earlier, there is this concept of virtualization, and virtualization makes or facilitates cloud computing to be feasible today. It's one of the pillars of what makes cloud computing possible today. And in fact, there are different types of virtualization, but virtual machines are the original type of virtualization that we have. So, in many years ago, when virtualization didn't exist, you would literally have to buy a server, install your application in it, on it, and then subsequently, if you were installing another application, you might have to buy another server at your physical boxes. There were companies that had hundreds and thousands of servers, and you may have seen what data centers look like. And those data centers were running single applications at certain times because they occupied all of the CPU capability, which was very expensive and incurred a lot of capital cost. Virtual machines was made possible because the specifications and the capabilities of these physical machines drastically improved over the late 90s and the early 2000s. And what happened there was we were having capabilities of CPUs and memory and the actual chipsets and everything being really powerful, that now if you ran a single application on a single server, pretty much most of the time it was sitting idle. So the advent and the invention of hypervisors made virtual machines possible. So you basically think about it, if you look at the screen, the way how it looks is you've got a physical machine. That physical machine has physical hardware in it, CPU, memory, network capabilities. It's got network cards, etc. And obviously it's got things like storage as well. Okay. And you then install something called a hypervisor. So hypervisor is this piece of software that has the ability to virtually carve out those physical resources and present it to the system to be able for you to build a virtual machine. On top of that hypervisor, you can then create isolated environments where you create these virtual machines. Each virtual machine having its own operating system, having a subsection of CPU capability, having a sub-allocation of memory. So if you have 2 terabytes of memory in your computer in the physical machine, you can allocate maybe 512 gigs of memory to one server, 256 gig of memory to another server, and so on and so forth. So you're basically chunking out and carving out those physical resources and allocating them to these virtual machines. The number of virtual machines that you can have on a physical server is going to ultimately depend on the actual total server capacity, total physical server capacity at the end of the day. Okay, and so this is another critical point to understand. So now that you have different virtual machines, what it means, therefore, is that I could be running some Linux workloads, some Windows workloads, and they can all run side by side. There is isolation between those servers. So if they do not need to talk to each other, you can enforce that, okay? Nevertheless, they're still sharing the same hardware. So the problem is, if there's a hardware fault, then obviously all of the virtual machines are going to be affected in some form or another. So that's something to be aware of when you're working with virtual machines and virtualization. And also there are 2 types of hypervisors that you can use. Okay, so there's type 1 hypervisor, which is what's known as a bare metal hypervisor. And that's really what cloud computing providers use at the end of the day. Here, what you have is you have the physical hardware. On top of that, you have the hypervisor. And then using that particular type 1 hypervisor, you're able to provision virtual machines with their own guest operating system. So Windows, Linux, whatever it might be. Type 2 hypervisor were in fact the earlier type of hypervisors when hypervisors started taking off. You've got the physical hardware, you've got a host operating system, which could be Linux, Windows, whatever it might be. And then you would install a hypervisor software on top of that, from which you can then create virtual machines that were used in your organization. So Type 1, the bare metal hypervisors offer you the highest efficiency. Examples include things like VMware ESXi, Hyper-V, Xen, KVM, etc. AWS, Azure, Google Cloud, they all use Type 1 bare metal hypervisors. Type 2, which is hosted, what we call hosted, is less efficient because here what you have is you have a host operating system and you have a guest operating system. So there's an extra layer involved in getting to the actual hardware to use its resources. So examples include VirtualBox, VMware Workstation. And obviously it's slower because the virtual machine has to talk to the hypervisor. The hypervisor has to send its request through the host operating system before it finally gets to the hardware. So there's this extra layer there. Now, when it comes to actually your laptop, for instance, or your desktop, if you're using a laptop or a desktop, probably one of the most common ways of setting up a virtual machine on your computer is to use a Type 2. Okay, unless you buy a physical server and install a bare metal hypervisor, which is what cloud computing providers do, and companies who are running production and service will do. Normally, if you want to just set up a virtual machine on your laptop, that's possible. One of the most popular software to install on your laptop is VirtualBox. It's free. You can download it and install a second operating system as a virtual machine. Like if you're running Windows, you could install Linux and you can get some experience on Linux and so on and so forth. Okay, now when it comes to making a decision as to what kind of capacity you need for your EC2 instances, for your virtual servers, you need to decide how much CPU you need, how much memory you need, what amount of storage you need, the kind of network bandwidth you want to use. In a traditional sense, if you were making that decision based on physical servers, and you needed to perform any upgrades or whatever it might be, you would buy those physical hardware components, open up the box of the server and install them. If you need to add more memory, some of you may have done that. You may have added more memory to your laptops. You know how it works. You basically open up the laptop, add a couple of more RAM chips, SODIMMs in it, and you've got more memory. You can't do that with cloud computing. You cannot visit an AWS data center and install more memory. You can't add more CPU chipsets in it and so on and so forth, right? So the way how cloud computing providers handle, your need to upgrade or modify the capacity of an instance is by giving you a vast collection of different instance types, all with varying levels of capacity and capabilities. Okay, so for instance, with AWS, you've got something called EC2 instance types that fall within a family. So there are several families of instance type, and each type has several different sizes. So you might have an EC2 instance that has a couple of gigs of RAM. You may have another one that's got 128 gigs of RAM, and it's got one CPU or 24 or 32 or 64 CPUs, and so on and so forth. And this is broken down in different types of EC2 instances, and they're generally categorized as different families. So the first family is what we call general purpose. Okay, so the general purpose is all-rounder. Okay, it's good balance of CPU, memory, and network. You use it for things like websites, small databases, maybe dev environments. It's intended to be used for smaller workloads, not something that requires excessive amounts of capacity and capability. You've got compute optimize. So examples include the C6i, C7G. This is heavy CPU work. So it's good when you want to do a lot of application number crunching and handling a lot of data fast. So gaming servers, batch processing, machine learning, inference, that kind of thing, very useful for that. Memory optimize. These give you huge amounts of RAM, and they're good for workloads that need to hold data in memory, large amounts of data in memory. So in-memory databases, real-time analytics. If any of you have heard of SAP, here's a good use case for SAP solutions. Storage optimize. These are fast disk throughputs for apps that require fast read-write and anonymous set of data sets. Good for data warehousing, Hadoop, and that kind of thing. And then you've got accelerated computing. These are GPU-powered machines, okay? They're good for machine learning, training, video rendering, and high-performance computing. So use cases include things like deep learning with regards to AI, 3D rendering, scientific simulations, etc. Okay, just give me a second. Okay, I'm just looking at a quick question, so I want to try and make sure, I answer your questions as well. Is there any best practice on how to choose an instance type for any use cases at hand? So using an instance type for production environment, if you want to make a decision on, okay, how am I going to choose my instance type for production environment, you need to do some pre-testing first. You need to build your dev environment in which you would test out different instance type. Obviously, you take into account if you're installing third-party software, what the system requirements are for those third-party software that you're installing, and then account for all of the necessary tools and utilities that are going to run on that virtual machine. The other thing that you need to do is you need to run tests, okay, on the type of traffic that hits that virtual machine and how much it can handle. So it's not a simple case of just making a decision on what VM you use. You need to actually do some testing and some analysis in a dev environment, in a test environment, before you decide what your production servers need to be configured with. So that's something to consider as well. So thank you for that, Vinayak. Okay, let's continue. Now, if you bought a laptop today, and usually it might come with Windows or something, and you decide that you want to install Linux on it, okay, what you would do is either you create a virtual machine, or if you wanted to just get rid of Windows altogether and go full steam ahead with Linux, you would reformat the hard drive. Okay, you would plug in, a USB stick that has the Linux operating system ISO image, and then you would install it from there. Right? You can't do that with the cloud computer. You can't get access to the physical machine. So you need a mechanism to actually configure the virtual machine, the EC2 instance, with your choice of operating system and any utilities and maybe even applications for that. That's where Amazon Machine Images come into play. So an Amazon Machine Image is basically a blueprint. Okay, it's essentially a bundled up piece of software, if you will, that contains the operating system and maybe any kind of utilities and any extra applications, all bundled up together as an image. And that image is hosted on S3 buckets. S3 buckets that are managed by AWS in what are called EBS snapshots. Okay, so they're basically hard drives. Okay, EBS, as we said yesterday, was like block storage, like hard drives. They're basically snapshots of that AWS then stores and collects and stores them in S3 buckets that they manage. When you launch an EC2 instance, you select one of those images to be deployed on your server. And that image is copied to the EBS volume to the hard drive that is connected to your server, so that when you launch it and you connect to it, it boots up with something like Windows or Linux or Mac or whatever it might be. So that's an important thing to appreciate here, that in order to get the right operating system, you need to select what's called an Amazon Machine Image when you're launching the instance. And you basically tell AWS through the console or through the API that you want this specific image. And that image might be a Linux operating system, Ubuntu, Debian, whatever it might be, or it might be Windows Server of a particular version, 2023 or 2025, whichever one you are looking for, right? And then it will set your machine up where it will basically copy that snapshot onto the block storage volume that's being attached to the server. And then when you connect to it, when it boots up, basically, it is launched with that operating system. So the good thing about it then is that it is, so just think of it as a pre-installed operating system software. You literally plug it into the new EC2 instance and it boots up exactly as configured, instantly ready for you to connect to it and remotely access it. So an AMI, or an Amazon Machine Image, will contain the operating system, Linux, Windows, etc. It will contain any pre-installed software or configuration. So you can get an AMI that comes pre-configured with some databases, for instance, in addition to the operating system. It's an EBS snapshot, and it basically becomes the root volume or the C drive. If you're familiar, obviously, with the C drive of your computer, it becomes the C drive of your computer if you're using Windows. It becomes the root volume if you're using Linux. And you also have certain launch permissions and block device mappings that are configured for it. So you can have some AMIs that have additional disks, additional volumes, block volumes that you can have it attached to. You get official AWS images, okay, official AWS AMIs for Linux, Ubuntu, Windows servers that you can use. Essentially, they are free to use. There are some images or there are some EC2 instances based on what you're installing. There may be some additional charges, but by and large, they're up to date and free to use. So the current version of Amazon Linux is 2023, for instance. You've got latest versions of Ubuntu. You've got various versions of Windows servers. So you might need to go to Windows 2019 because your application requires that particular version. It will not work on a later application. So you have all of this ability you have all of this backward compatibility as well. You can actually also procure AMIs from the marketplace. Okay, so there's the AWS marketplace, and there are a lot of third-party companies that distribute their software as Amazon Machine Images and sell them on the AWS marketplace, making it a lot easier for you to basically pick those images and have them configured for your server. So WordPress, Nginx, SQL Server, so on and so forth. And a lot of them are available there as well. You find a lot of firewalls and software versions of firewall solutions available as AMIs from the AWS marketplace. You can actually create your own custom AMI. Now, this is really interesting because here what happens is you literally have to create your server. You have to launch a standard AMI. Maybe you take one of AWS Manager's AMI, managed AMI, and then you will set it up and configure it in the way that your corporate organization prefers. So maybe they need specific software installed. Maybe they need specific utilities installed. Maybe you want to harden your server so that certain resources, certain services and tools are disabled by default. Those configurations can then be saved as an image and become what we call the corporate AMI, the corporate image for the organization. And then that ensures consistency whenever the company deploys new servers. We know exactly what's going on in the server. This increases security posture and also reduces any kind of discrepancies and administrative burden or troubleshooting and bottlenecks along the way. Okay, so that's all about Amazon Machine Images, and it's a critical part of working with cloud computing. And regardless of whether you're using AWS, Azure, Google Cloud, or any other, you usually have to handle and work with these images in order to have your machine configured the way you want it with the right operating system, the right set of tools and services as well. In addition to that, once the actual AMI is deployed and the server is up and running, you can go ahead and install additional software as well, as with any other virtual machine. So when would you actually use EC2 instances? So EC2 instances gives you full control. It falls within the infrastructure as a service category of cloud computing. If you remember in day one, we spoke about IaaS, PaaS, and SaaS. Okay, so EC2 instances fall within the IaaS category of cloud computing. And ultimately what that means is you've got more control over it, but then therefore you have more responsibility as well in order to ensure it's secure, fully managed, patched, updated. Did you install the antivirus on it? That kind of thing, right? So use EC2 instances when your app needs a specific operating system, a custom Linux distribution or Windows server. You have long-running workloads, perhaps a process that runs 24/7. Maybe it's an email application. Maybe it's an e-commerce application. Lift and shift migrations. If you want to move your on-premise servers, if you're moving to the cloud and you want to get rid of your on-premise servers, then EC2 instances is the way to go. It makes it easy just to do a lift and shift job rather than re-architecting or re-engineering the application. If you need root access, this basically means if you need to install custom software, then you need to have an EC2 instance. If you have legacy applications that run only on specific OS versions, I mentioned earlier, you may have some old software that needs to run on Windows 2019 or 2016. Well, that's when you would use EC2 instances. And if you need apps that need stateful or persistent local disk, so games, databases, that kind of thing, you would need EC2 instances. Consider alternatives, okay? When you have short-lived tasks, then you can use Lambda. We'll talk about Lambda in a few moments today. You could use containerized applications. This is a different type of virtualization, allows you to create containers and build containers instead of fully fledged virtual machines. And if you, for instance, require managed databases, then rather than installing a database on your server, so you could install a database on your server like Microsoft SQL Server or MySQL or PostgreSQL. You can install all of them on your servers, on your EC2 instances, but then you have to manage them. You have to patch them. You have to update them. You have to secure them, all that amazing administrative effort. Instead of that, you could use alternatives available from AWS, which are managed database solutions. So managed Microsoft SQL Server, managed MySQL Server, that kind of thing. And so you can use that instead of using EC2 instances. Static websites, I mentioned this already, and I've explained how static websites work. So S3 and CloudFront, no servers needed. You don't have to worry about managing, patching, updating, install the antivirus, install the making sure that all of the software has been updated and stuff like that. You don't have to do any of that. You can run a fully fledged end-to-end static website on S3 and CloudFront, and AWS scales it and manages it for you. If you need event-driven processing, and a lot of e-commerce applications and a lot of applications that you see today are event-driven. And what we mean by event-driven is something happens, and so we react to that. So someone puts an item in the cart, and so we need to update a database somewhere that there's this item in the cart. Someone goes to the checkout, clicks on the checkout button, and so we need to bring up all of the items that are in the cart available for the checkout to calculate what's the total cost. Okay, these are called event-driven processing. You could have them running on an EC2 instance. There's nothing to stop you doing that. You'll find it a lot cheaper and more efficient if you use something like Lambda and SQS, and we'll talk about Lambda shortly. So serverless, if you need serverless APIs, again, Lambda and API Gateway are great for that. You can, again, all of these things can be done on an EC2 instance, but doing it on an EC2 instance can be more costly, more inefficient, and adds to the administrative burden that you might have as an organization. Okay, so I'm going to go ahead next and take you into a lab, and we're going to launch an EC2 instance. And what I want to show you here is how we can deploy the same JSON Coffee website on an EC2 instance. And there's a little architecture diagram that I want to go to. Before I do, are there any questions that you have so far? Feel free to put it in the chat because it'll be a lot easier to answer, and everyone can have that. If there are any questions, we just take a quick minute before we progress, and I'll reshare the screen for my lab environment. I'll just stop the sharing here, and I'll reshare the other screen. So just give me. Okay, so I'm just resharing the other screen where I'm going to walk you through how we can set up the same JSON Coffee website. So this one is obviously running on CloudFront, and in front of CloudFront, behind CloudFront, I've got my S3 bucket, right? So hopefully you were able to connect to that, which I've put in the chat. Okay, so let's proceed. So also, before we go any further, I'll put in the GitHub repo for this because I've updated the GitHub repository and it's got in it the codes for the Compute Today section. And so what that means is if you carry out the homework for today, then obviously you need access to the code as well. So there it is. The link is in the chat. Let me know if you can get access to that or if there are any issues, and I'll try and help you out there. Okay, so let's proceed. Okay, so I'm on my AWS Management Console, and what I'm going to do is I'm going to launch an EC2 instance and showcase how we can create that same website. So this JSON Coffee website is running off a CloudFront distribution point, and behind it is an S3 bucket. Instead, we're going to deploy the same website, but this time on an EC2 instance, and show how that would work. Let's bring up the slide just for a couple of more minutes, because what I want to do is I want to show you the architecture diagram of what we are doing. Okay, so what we're actually trying to achieve here is we're trying to host our website on an EC2 instance. And again, in this particular use case, I hope you'll agree with me that an S3 bucket in CloudFront makes more sense. It's more cheap, less cost, and obviously there's a lot of security already built in with CloudFront's capabilities. Nevertheless, if you need to do it with EC2 instances, that can be done. So the architecture is like this. You need to select a region where you're going to deploy your EC2 instance. And specifically, you actually need to select an availability zone, as I mentioned earlier. You've got your developers. You might be the developer, or you might have a team of developers that build the necessary application code, in this case, is just one single HTML document, but it might be a more complex application code that can sit in a repository. Now, you can use external repositories, or you can use something like Amazon S3 as a repository. You can obviously use GitHub as a repository and so on. So the choice is really yours. For this simple example, I'm going to create an S3 bucket and store the HTML document in that S3 bucket. Then you've got your cloud engineer, hopefully that's you, who's going to deploy an EC2 instance and deploy that application, in this case, just a simple HTML file, to the server. Okay, so you're going to have to create or use a VPC, a virtual private cloud. Now, we're not covering virtual private clouds in this series. However, this is obviously part of the complete AWS training that we can offer. But ultimately, when you deploy an EC2 instance, it needs to go in a VPC. A VPC is an isolated network environment that you deploy in a specific region. If you think about the way how it works, you might be deploying multiple applications across multiple servers that may be unrelated to each other. You can have separate VPCs, separate isolated network environments for each application that you deploy. This ensures isolation and improves your security posture. Certain types of resources like EC2 instances have to be deployed in a VPC, and more specifically, a subnet in a VPC. This subnet is tied to a particular availability zone. Other types of applications and other types of resources like S3 buckets do not sit in a VPC. They sit in the entire region. They are accessible across all 3 availability zones or all 6 availability zones if you happen to be using North Virginia, for example. So when this engineer is going to deploy an EC2 instance in a particular VPC, okay, he then needs to configure that EC2 instance to set up as a web server, okay, something you didn't need to do with an S3 bucket previously. Download any kind of repository code from the S3 bucket and configure it so that users on the internet can access that website that's running the resume website, right? And so normally one way of doing it is that you can automate the entire process. So the cloud engineer can deploy the server, run a script so that this server can automatically download the application code and install it on this server, okay? That saves the engineer having to manually log into the server and run commands individually. So the script that he will run may be used to install web server software, for instance, the Apache web server software, install any databases if it needs databases and it's not using external RDS databases, automate any deployment of application code to the web server, and so on and so forth. Make any configurations, perhaps set it up so that it can send a lot of traffic and logs to CloudWatch. You remember we spoke about CloudWatch yesterday briefly, that kind of thing. So all of those tasks can be automated so that at the time of launching those servers, they run automatically and your server is up and running fully configured. Okay, now, can you, okay, before I actually ask the question, one of the things that therefore needs to happen, right, is that this server needs to talk to this S3 bucket, okay? It needs to tell the S3 bucket that I want to download those files and I want to get access to the repository, right? So as a result of that, you are in a position where you need to then, have this EC2 instance talk to the server. Can you tell me what would be required to facilitate that communication between the EC2 instance? So the EC2 instance tells the server, hey, I want that code and I want to download it to my computer. Any guesses? What does the server need in order to be able to access that S3 bucket? Would you be able to tell me that? Okay, an S3 access point, probably well before that, before we even talk about an access point, what is it that any resource needs before they can communicate with another resource of a different service on an Amazon platform? So yeah, thanks, Vinayak. So basically a CLI, that's just a command line interface. Certainly you can use a command line interface to send and issue commands. Okay, thank you. Access keys. So access keys are a method by which the EC2 instance was connecting to the S3 bucket to sort of authenticate. But there's something else that is required, and access keys are probably not the best thing that you would use. If you recall from section, day one, we spoke about identity and access management. We spoke about IAM users, groups, roles. What would you use, therefore, to allow for that communication to take place, to permit that communication to take place? Would you create an IAM user with a set of access keys? How would the server authenticate and be authorized to connect to the S3 bucket? Anyone want to try? Okay, service account with access. You're nearly there, Vinayak. Thank you. Just give everyone another 30 seconds. Anyone else? Okay, so on Monday, we spoke about the fact that you can create an IAM user, an IAM group, and an IAM role. And an IAM role is particularly useful in this particular use case. Okay, so what an IAM role does is it allows one set of resource to be permitted to authenticate and be authorized to access another resource. And the way how we do it is we create a set of permissions and we attach it to the IAM role. So this permission, this policy, we create a policy, it's written in JSON. And the way how it works is we define in the policy which buckets, or if we're accessing all the buckets, what buckets are we accessing, and exactly what we can do with those buckets. Can we add files to the buckets? Can we retrieve files for the bucket, etc.? Are we allowed to delete the bucket? Those are all permissions that can be defined in the permission set in the IAM policy. And we define what actions we can take against the bucket. We then attach that policy to the IAM role and then attach the role to the EC2 instance in something called an instance profile. Okay, and now as a result of that, the application or the script, even for that matter, that's going to download the code is going to be permitted to do so. Okay, because the role is giving the EC2 instances permissions based on the permission set defined in the policy to access the bucket and download the source code repository from it. So then when we run the script to copy, the index.html file from the bucket to the EC2 instance, it's going to go ahead and it will actually happen. Otherwise, you're going to get an access denied and it's not going to be able to download that. Okay, so the first thing we need to do is to create our S3 bucket, upload our source code. In this case, it's just an index.html file, create an IAM role. Then we can launch the server, make sure we attach the IAM role to the server, and then our users can access the actual EC2 instance over the internet and access the website in question. Okay, Hitanshu, yes, exactly. Thank you so much. That's exactly what I was looking for. Thank you. Okay, wonderful. Okay, so let's get into the AWS Management Console, and I'll just show you how we do this one. Okay, so first I'm going to go ahead and set up my S3 bucket. So we're going to create a new S3 bucket for this one, and I'm going to call this one. So there's the S3 environment, normal general purpose bucket. Okay, and it's going to be called I'm just going to give it my name so that I can get the name. Resume repo. Okay, Rajesh Resume Repository for short, right? And no need to do anything else. And I'll just create the bucket there. Okay, so that's my bucket created. I'm also going to go ahead and upload the file that I'm interested in. So give me 1 second and let me just get the file that I want to copy across. So here, so it's the resume, is Jason's resume. Okay. And Yeah, not my resume, put Jason's resume, and we just drop it in there, and I'll upload that as well. Okay, so we're just uploading Jason's resume there. Okay, and so that's the bucket, and it's got the file in there that we're going to use, and that's going to be the application source code repository and or what have you. Okay, so the next thing that I want to do is actually create the IAM role in question. Okay, so we'll go into IAM. So I'm going to go into IAM. Okay. And I've previously shown you how to create an IAM user. Okay, so this time what we're going to do, what I'm going to be doing is creating an IAM role. Okay, so we'll click create a role. And it's an AWS service role because we're giving the role to a service entity to access another service entity. Okay, so you can create different types of roles. If you need to do cross-account access, you'll be creating an AWS account role, a web identity role, so on and so forth. And the service that we're assigning this role to is EC2. So we're going to select EC2 from the list. So EC2 instances are going to be permitted to assume this role. Click next. Now we need to give the role a set of permissions, as you saw in the slides, right? Now you can create your own IAM policies that's far more granular and improves your security posture. For the purposes of this exercise, I'm going to use one of the standard managed policies that AWS offers you. I'll do a quick search for S3, and there is an S3 read-only access. So that means that the EC2 instance can download stuff, but not upload stuff, right? And this just makes it a little bit secure, but you can go even further by specifying the exact bucket that you're going to talk to. You can't talk to any of the other buckets. That's when you create a custom policy. Okay, and I'll click next to that. And we'll give this a name. So I'm going to call this resume, IAM policy, okay, something like that. Okay, and then I'm going to click create role. So that's creating my role that I can then assign to an EC2 instance so that that EC2 instance can assume the role and be able to connect to the server. So if I just search for it again, so there it is. And I can look at the permission that it has. So it has this get everything. Okay, so get all objects from S3. There's some other stuff in there as well. Okay, but definitely it can get access to buckets. And which bucket at the moment is any of the buckets. Okay, so we can reduce or we can improve the security posture as well. Okay, so I've got the policy in place and I've got the role in place as well. So let's just go back to the role. Okay, so okay, there it is. And then what we can do next is obviously go to our console again, and this time go to EC2. So now we're going to launch an EC2 instance. Now, as I mentioned in the slide deck a few moments ago, there's a script that we can run. I'll show you the script in a minute. Let's just walk through how we're going to set up the server, and then at the end, we'll attach the script to it, and then I'll show you the script as well. So like with anything on AWS, from the left-hand side, you've got a lot of menu options available. We're going to go with EC2 instances. So we're going to launch an EC2 instance. Okay. And this is where we define exactly how we want our EC2 instance, our virtual machine configured. Okay. So I'm going to give this server a name. So Jesh web server is something like that. And this is where we select our AMI. So you can see that there are different AMI options available to us. Okay, we can browse more AMIs, either include AMIs from AWS Marketplace, the community, or we can use one of the standard AMIs that AWS offers you. So here we've got the Amazon Linux AMI. The latest version is 2023 kernel 6.1. I'm going to use that one for the purposes of this exercise, but you can deploy Windows servers, Red Hat servers, Debian, Mac OS, so on and so forth, right? And if we scroll a bit further down, it gives you things like AMI ID, when it was published, and a few other pieces of information like the architecture. You've got the Intel x86 architecture, for instance, that we're currently using. I mentioned earlier about instance types. Okay, so instance types obviously is where you can obviously choose the type of instance. So here we are going for general purpose instances, and specifically T3 micro, which only gives you 1 GB of memory. Okay, and this is enough for the purposes of this web server. It's got 2 virtual CPUs. It's got 1 gig of memory. That's pretty much all it has. So it's not a very high powered machine, but we don't need one for this particular use case. Key pairs are something that you may need if you want to remotely connect to your server using remote access tools, and you want to supply the encryption decryption keys to unencrypt your connection. Okay, so key pairs are often used when you're remotely connecting to a machine using a client application. For the purposes of this lab, we don't need it because there are other ways of connecting to that server. There's something called EC2 Instance Connect, which uses a web interface. There's also something called Session Manager, which is far more secure method of accessing your service remotely from the internet. The network settings are really important. This is exactly where you would define where the instance goes, which availability zone it goes in, which network, which VPC it's going to go in. Now, AWS provides you with a default VPC in every single region. So we're going to make use of that. And I could, for instance, also make a decision on which availability zone I want to place the server in. So if I choose, for instance, this one over here, availability zone US East 1A, then that's where the server is going to be deployed. Okay, so I'm just going to leave it as no preference for now. The server is going to be front-end facing, which means it's going to have an elastic IP address or a public IP address, so I can connect to it on its IP. Okay, and the next setting here is really important. The next setting is a security group. Now, when you study the AWS Solutions Architect course, one of the things that you really need to understand is the networking architecture. Use of security groups and network access control leads to actually define exactly what sort of connectivity, what traffic you're going to allow in, on what ports and what protocols, because you don't want to expose the server out to all of the necessary ports and protocols, because then that increases your attack surface, right? So you define exactly the connections that you will permit inbound. This is a web server. So the only connection that we need to permit inbound from the internet from end users is HTTP, or better still, HTTPS. Okay, so we'll create a security group, and I'm going to call this one, actually, let's create a security group. I'm going to call this one Rajesh. We'll just call this one Web Service Security Group, actually. Okay, and I'll give it the same name for the description. So you can normally provide a description as well. Now, by default, because I'm launching an EC2 instance that's a Linux machine, it's already suggesting that I enable SSH. SSH is a remote connection methodology or solution that allows me to connect using something called Secure Shell on a particular port called port 22. This basically gives me remote access to the actual computer, to the actual server. But we need one more. We need a security group to allow web traffic inbound. So I'm going to create a security group for HTTP access. This means that users on the internet can connect to this server over using a web browser. Okay, so HTTP will permit that, and it runs on port 80. If I wanted to use HTTPS, I would need to install something called an SSL certificate to encrypt that traffic. But for now, we're not going to bother doing that. Okay, and obviously the source of that traffic, sorry, that just got cleared. We'll just do it again. So HTTP traffic on port 80. The source of that traffic is also something that you need to define. So you can limit the source to a specific IP range, or you can expose the server out to the entire planet. Okay, and this 40/0 means exactly that. It means all external networks. Okay, and that includes the internet as well. So that's the security part done in terms of the type of traffic going to allow inbound. And then if I go into advanced details, here's where you can see where I'm going to add that IAM role. Remember, we created the IAM role a few moments ago. So I'm going to have the option to select the IAM role. And I think it was that one, Rajesh Resume IAM policy. That's the one that I created. So that's the role that we're going to be using. And if I scroll a bit further down, and there are lots of different settings that you would need to learn about, especially if you're interested in taking the Solutions Architect exam and understanding it and working with the technologies, but obviously this is all stuff that you would need to get hands-on experience in as well as understanding the core fundamentals of all of these different options. And if I go all the way to the bottom, this is where I can add a script. So the script, basically, depending on the operating system that you're using, can either be something called a bash script for Linux or PowerShell for Windows. You can use some other scripting approaches as well, but by default, these are the two options that you would go for. Now, the script is available in the GitHub repo as well, and I'm going to quickly bring that up so you can see what it looks like. And it's written, sorry, just 1 second, and it's written, and it's basically a bash script, okay? If you're new to this, please don't be alarmed. This is fairly easy to pick up, okay? And it's actually not very difficult once you start working with it and getting some hands-on experience on it. But essentially all this script is doing, and I've annotated it with these hashtags that basically comment out and tell you what's happening. So this is updating the operating system, the OS packages. This is installing something called the Apache Web Services, okay? So HTTPD is the Apache web server itself. This is enabling it to start up on boot, okay? This is clearing any default web root content that might already be there. And this is the magic. This is where actually the HTML file from that S3 bucket is being copied to the server, okay? So you'll notice that there's a placeholder here where I need to add my bucket name, okay? Because I need to obviously tell the server which bucket to pick up the actual application code from. So I'm just going to get rid of that and just make sure I pick up the right bucket name. So it was Rajesh resume repo. Okay, and we're going to just paste that in there. There's a space after that, /var/www/html. This is a directory on the EC2 instance. Once the EC2 instance has been configured with Apache, it will have a directory called HTML. And that's where literally we're copying this file or anything in this bucket for that matter. So we're doing a full sync. Anything in this bucket, we're copying it into that directory. That's literally all this is doing. And then it's basically setting some permissions. And finally, it's starting up the web server. Okay, so this is the actual script. I'm going to literally copy that and paste that in here. Okay, so just making sure that there weren't any errors. So there, it's going to install an update, install Apache, enable the service, copy all of the files from the bucket to the HTML directory of the server once the server is available, and then start the actual service. And with all of that in place, we're going to go ahead and actually launch the server. Okay, and I did miss something. Okay, right. So we set that to all the zeros. That's fine. And just check if there's anything else. Yeah, that's okay. Just going down and making sure I've got the IAM instance profile. Yeah, so that's in place. And make sure there isn't anything missing on there again. Let's try that again. Okay, we've got two of them. Let's just do that again. That should now, there you go. Okay. So once the instance is getting launched, it's going to take a few minutes to actually come up, because now what's happening is the AMI is being sent to the server as a snapshot. A root volume is being provisioned and attached to the server, and the server is going to go through that script to run through the complete installation of the Apache Web Services and also to copy the files across to the server. So that's going to take a few minutes to run. I'll let that run. It says initializing. Depending on the operating system you use, it can take 2 to 5 minutes. So we let that run, and I will quickly take any questions if there are any questions as well. Okay, let me just, okay. Any questions at all so far? Okay. So I've got a question from Vinayak. I missed adding the HTML file in the S3 before launching. Yeah, absolutely. So then that script is not going to be able to copy any files. The way around it is you may have to connect to the server itself. And as long as it's got that role that you should have configured, then you can manually copy the file. Once you've logged into the server, you can manually copy the file from the bucket to the actual server. Okay, and you would need to issue a command for that. So either you could do that sync command, or you could potentially run AWS S3CP for copy command as well. Okay, so you can actually run that command by logging into the server and manually doing it. Or the easiest way, if you just want to run through the same exercise, is just terminate the server, go back to the S3 bucket, upload the file to the S3 bucket, and then launch a new server. Okay, and then that should then work. So that's an answer to the night there. Hopefully that was helpful. Give me 1 second. Okay. Sorry, just seeing if there are any other questions in the Q&A. All right, let's, if there are no more questions, let me just share the screen again. And okay. Let me share the screen. Okay, let me know if you can see my screen again, sorry. Just to make sure that it's visible, if I could get a thumbs up on that. Yep. Okay. Awesome. So this is taken about, say, 2 minutes or whatever. So actually, if we take a look at the server now, so the server is running. The server has passed some system integrity checks. Okay, this is something else that you need to be aware of if you're planning, when you're working with servers in the real world, you know what these checks actually mean. But the server is now fully up and running. So what I can do is I can take the IP address, okay, and I can connect to that IP address over the internet. And there you go. I've got my website up and running. So I can now physically connect to that web server. So for the purposes of today's session, if I put that IP address in to the chat, you can access it as well. Okay. Okay, yeah. There is, give me 1 second. Ibi, you've got your hand up. Hi. Are you able to unmute? I don't know if you're able to unmute. Um, Hi, Ibi. I think you had your hand up. I'm not able to. I'm just trying to ask you to unmute and see if that works. If it doesn't, feel free to just drop a question in the chat. Okay. Okay, let me just see if there are any other. Oh, okay. No, it's an error. Okay, no problem. Okay, so essentially what we have here is an example of I'm able to now host this website on an S3 bucket behind a CloudFront distribution. I'm also able to host the website on an EC2 instance. So there are different ways of doing this, right? And you can see the different use cases of why you might choose one over the other. In the case of a simple website, it makes a lot of sense for us to be using S3 and CloudFront. In the case of something that perhaps may be more complex and needs a lot of processing and sort of back-end server-side scripting, that's when you would really want to use an EC2 instance because you need the CPU capability. If you're just presenting HTML, then it makes a lot of sense to just go with S3 and CloudFront. It's a lot cheaper, a lot less management overhead. In the case of this EC2 instance, I have to manage it, I have to patch it, I have to install antivirus on it, all of that stuff. I have to back it up because it's infrastructure as a service. AWS doesn't do any of that for me. So there's administrative burden on my part, okay? All right. So hopefully you found that useful, and I would strongly request you to actually try that out in the lab as well. You've got access to the code as well as the script in the GitHub repository, and it's just great to build on hands-on practice. So let's move ahead. Let me bring up the slide deck again. Bear with me one second. Okay, want to move on to containers next. So quick recap on virtualization. With virtualization, we had a physical server. You had the memory, the motherboard, the CPU, the RAM, lots of fans to keep it cool. And we ended up adding a hypervisor onto it. AWS uses something called the Nitro hypervisor. You've got VMware, ESXi, and you've got Hyper-V and Zen, etc. AWS now uses Nitro. And you can spin up all these different virtual machines. I'd like to bring your attention to the fact that the reason why we are spinning up different virtual machines, even though they're running roughly the same guest operating system, is because we might be running different runtime environments. Generally, developers, when they're working on applications and when you're an organization and you go through an application lifecycle, the development team might be using a later version of different pieces of software than the version that is currently in production. You'll see that node is 21.6.2. Here it's 18.12.0. Okay. And the reason why production tends to lag behind development is because production, usually you want it to run on more stable versions, things that have been tried and tested. If Node comes out with the latest version today, whatever it might be, you don't want to be running that on production until you've checked that your application can consume it, and there are no errors and there are no issues and there are no bugs or what have you. Okay, so you go through this life cycle of dev, test, and prod, and maybe even a sandbox where you will need multiple servers that run in isolation and don't interfere with each other in any way. This is why virtualization is really fantastic, because previously I would have to have 4 separate physical servers, which is just crazy, right? It's a lot of expense to take care of. So this is great, but one of the things, or one of the downsides of virtualized solutions, we just never satisfied, okay, is the fact that you can see I'm using the same guest operating system. There's a lot of resources being consumed by a lot of duplication happening on my physical server. It's the same guest operating system that's running, maybe different runtime environments, but perhaps for the same versions or different versions of the application. So there's a lot of resources that's going to be used up by your guest operating system, which does one of 2 things. Reduces the number of applications I can actually run on the physical server, because even these guest operating systems are going to take up resources. So it reduces the number of virtual machines I can run on the server. And 2, it means I need more servers. So if I wanted to run 100 of these applications, maybe on each physical server I can run 10, therefore I need 10 servers. Instead, we come up with something called application virtualization or containerization. Application virtualization basically says that we take the entire application itself and we bundle it up with all of the necessary runtime, libraries, etc., into something called a container, okay, that works in its entirety and consumes and shares an underlying operating system, an underlying host operating system. The way how it works is we still got our physical server, we still need the memory, the motherboard, the storage, the CPU. We still need those fans, but instead what we now do is we install something called a host operating system, whatever that might be, and then we install a container engine. A popular container engine out there is called Docker. There are other container engines as well, especially if you're looking at things like Kubernetes, but Docker is a really popular one to be using. And then with that, the application now is going to be packaged with all of the libraries, all of the runtime, all of the necessary tooling that it needs as a container and deployed on your server. So the application is now using the Docker engine to send requests that it needs for the hardware resources via a host operating system. And the Docker engine or the container engine takes care of that communication. Hopefully you can see just from the visualization, I've got lots more capacity available on this physical server, and I can deploy far many containers than I could have virtual machines. There's a slight downside to that. I won't go too much into it in the sense that we're now sharing the same guest or host operating system. Each application doesn't have its own guest operating system, and this may cause some issues from a security standpoint when you think about multi-tenanted architectures, depending on which industry you're in, that kind of thing. But hopefully you are able to appreciate here that I've just exponentially improved or increased the capabilities of that same physical server by using containerization, using something like Amazon ECS on AWS or Kubernetes, for instance, if I choose to use that. Okay, so let's move on. So that's another type of compute service. You can run the same application, that same website, that same resume website can be run on an S3 sitting behind CloudFront, an EC2 instance, and you have a lot of management overhead, or it could be running as a container. Okay, and then it doesn't stop there. We can use Lambda next. Okay, so Lambda is event-driven compute and is actually a very amazing and capable service to build what we call in the industry as serverless technologies, okay, serverless architectures and serverless applications. With EC2 instances, and in some cases with containers as well, you're managing the underlying hardware. You need to patch them, you need to update them, you've got lots of administrative overhead. They also run, unless you switch them off, 24/7. Okay, so you're paying for them at that rate, at the per second, per hourly rate. S3, you're paying based on usage, how much data you stored, how many requests you're making. Lambda, on the other hand, works completely differently. You literally pay for the number of times or the amount of time that the actual code executes. Okay, so you're paying for execution. You're not paying for an idle machine sitting around, not actually doing anything. So the scenario is, let's say you want to have, and you can see I really like coffee. Let's say you want to build an e-commerce website for your coffee brand that you're selling globally. Okay. So the idea is it's a coffee shop business. You're building an e-commerce website. Customers will place orders at different times of the day, random, okay? And website offers standard e-commerce services. So things like browsing the products, adding to cart, going through a checkout process, initializing and connecting to a payment gateway, Stripe, PayPal, whatever it might be, and then finally completing the transaction. In a normal EC2 setup, the architecture is going to look something like this. So you got your hypervisor, and maybe you've deployed one server. Obviously, you would deploy many more servers, many more EC2 instances in order to afford, provide that reliability and high availability. And different users are going to come at different times of the day to place their orders. So we've got our friend here, his name is Menio, and he connects to Beancraft. So this application is running on the server, okay, on an EC2 instance. It's managing both front end and back end, incidentally, on the same instance. And he decides to order some coffee. So he adds some of the coffee to cart. He then goes through a checkout process and then finally decides, okay, he's going to make the payment. That happened at 10 a.m. today. A little later, at 12 p.m., another friend of ours decides to do the same thing, visits Beancraft, wants to buy some coffee, goes through a checkout process, payment gateway, and she places her order. 2 o'clock in the afternoon, George does the same thing, connects to Beancraft, adds to cart, checkout, payment gateway, and so on and so forth. It continues. This is great. This is fantastic. But here's the downside to setting up this architecture where we're running stuff on an EC2 instance. The first thing is You got dedicated instances running until you terminate them. If you don't know when the orders are going to be placed, you're running your servers 24/7. AWS offers certain discounts if you're going to run your instance for longer term, like 1 to 3 years, but nevertheless, you're still paying for every second that that server is up and running. You do get a choice of operating system, Linux, Windows, etc. But in this particular case, it really doesn't matter. You can decide on the scaling strategy, how many servers you need based on the amount of traffic that are coming in. We have something called auto scaling on AWS that allows you to configure automatically scaling and adding more servers to the fleet to cope with the load, and then terminating them when the load or the traffic reduces. So you get to decide on a scaling strategy, which is brilliant, and it kind of like helps you manage costs a bit better. But remember, your servers are still running potentially 24/7 throughout the year. You must patch and manage your instances. There's a huge effort that goes in managing patching alone, okay? Knowing exactly which patches to apply is a task in itself, because it needs to be tested. You need to make sure that the patches are not going to break the server before you deploy them. You're paying for every second the server is in the on state, and it can handle long-running processes. So in this case, it's not really required. When we talk about long-running processes, we're talking about a lot of number crunching, extensive amount of processing that needs to go in. Really and truly speaking, there should be a better alternative to something like an e-commerce site like this coffee shop. And yes, you can install almost any type of applications on your servers, because you've got full root access. So you can install any application, any database. You can install your spreadsheets if you wanted to, and you got that flexibility available to you. And you got dedicated storage as well with the EBS volume. So you may connect to an EFS file system as well that you need. Okay, so that's all fantastic. Now, AWS Lambda is different. AWS Lambda works differently. With AWS Lambda, it will handle the backend processing for you. So the add to cart, the checkout, the payment gateway, it can take care of that for you. Those are all server-side scripts, if you will, that need to run. We can't run them on an S3 bucket. Okay, remember, S3 buckets can be configured as a website, but only a static website. It can have some JavaScript that can run in your browser, but it can't do any computational work for you. Nevertheless, the front end of that website can sit on an S3 bucket served behind a CloudFront distribution. Okay, so all of the browsing that you're doing when you go to a supermarket, all of the products that you're just looking at and not actually picking up anything, okay, that can be taken care of in an S3 bucket as a static website service. We can then use Lambda, which is an event-driven computing service, which comes with an amazing set of flexibility in terms of how it is actually consumed. So we've got our friends Menu, Alice, and George, and they come at those same times, and they're busy browsing the website and looking at all the wonderful coffee that I'm selling. And behind the scenes, I can provision a Lambda environment, a Lambda function environment. So AWS Lambda spins up what are called execution environments inside hardware isolated, what are called micro VMs. These are micro virtual machines running through or using an open source virtualization software called Firecracker. And the way how it works is it's very different from traditional virtual machines. With traditional virtual machines, they take a long time to boot up. We're talking about a few seconds to a few minutes, so it might not seem that long, but it is long in computational terms. And you've got containers that are very fast because they don't need to boot up as such. They just are spun up. They just get launched. Okay, but Lambda functions work differently because we're using this what are called micro VM technology to create execution environments in which the Lambda function literally will execute based on a trigger or an event that takes place. So the way how it works is when Menu comes in, he adds a particular item to cart. That action, that event, executes a Lambda function, the add to cart Lambda function. When he decides finally he's going to go to checkout, okay, which may be an hour later, right? He'll click the checkout button. That's going to execute another Lambda function. It's in the cart, it's at checkout, and he decided to, take a break. and come back later and make the payment, that's going to execute yet another Lambda function. These Lambda functions that get executed, okay, are executed in a Lambda execution environment. And then once they're executed, they're terminated, or they continue to exist for a little bit, but then if they're not used again, that environment is terminated. And so what happens is with Lambda functions, you're paying only for the time that it takes to execute those functions. We're talking about milliseconds here. So as a result of that, because you're not paying for the server running 24/7, because you're only paying for execution time, your cost is going to be drastically reduced, far, far drastically reduced when compared like for like. Okay. Now, something to be aware of when Menu first adds an item to cart, okay, it's going to provision in that moment the environment. The micro VM is going to provision that execution environment, and that can take a little bit of time. And again, we're talking about seconds here only, but it can take a bit of time. That's known as something called a cold start. But if we have more people come in at the same time, adding to cart roughly at similar times, it reuses that same execution environment. If we take a break, it takes a bit of time before the next person comes in. So Alice comes in at 12 p.m. to add something to cart, and that was the next customer. Then obviously it's going to provision another environment and execute that Lambda function. But the beauty about this is you're only paying for execution time, okay, rather than paying for your servers or your containers running 24/7, and you have that issue to handle where the cost is going to be much higher than using this environment. The reason why we are able to actually do this is because we've still got our front end, our users accessing the website on an S3 bucket. We don't need a web server to actually promote or showcase that website and showcase our products. Okay. So this is the benefit of using Lambda as part of the backend processing of your application. Your front end can sit on an S3 bucket and showcase all of the wonderful products you're selling. The back end can be handled by Lambda functions, and you can run a complete e-commerce website without managing and handling servers. So just a quick recap. So serverless execution environments managed by AWS. Unfortunately, you can't choose the choice of operating system, but then the trade-off is there. AWS will automatically scale all of the incoming requests. Okay, you don't need to provision servers for that. It handles the patching, the maintenance, the infrastructure management. No need to install antivirus software. You pay only for request and execution time, and this is in milliseconds. You don't pay for idle time. Okay, right? It's best suited for short-lived event workloads. So there is a time limit or timeout period for these functions to execute. Currently, it's set at 15 minutes per invocation. Okay, so if you have long-running processes, you're doing some complex calculations, that's going to take half an hour. You need an EC2 instance. If you're going to run an e-commerce website like this, Lambda does the job perfectly well. You don't have dedicated persistent storage. However, any of the activities and orders and orders that are placed, transactions that have taken place, can be shipped out to an external database like DynamoDB or Amazon RDS. So that's not really too much of a problem either. Okay, so hopefully you can see the core benefits there of sorry, one second. Hopefully you can see the core benefits there of making a decision on which service you're going to use for your computational efforts in order to serve your application. Do you use S3 and CloudFront? Do you use AC2, ECS? Do you use Lambda? That kind of thing when you're making decisions on how you build your application stack. Okay, so let me just give me 1 second. I'm just going to bring up this page again. Okay. Are there any quick questions, by the way, before we proceed? Any questions at all? Mr. Kim, you've got your hand raised up. Do you want to just drop a quick question in the chat.
Hello? Hello? The concepts are very clear to me, and I'm
Yeah,
really,
okay, no problem.
insights of it.
Okay, so next what I want to do is move on and talk about decoupled architecture. So far we've been looking at things like, front end, the front user interface, and then I mentioned with the Lambda functions, the back end, the back end processing that happens. So immediately, hopefully you're starting to think, okay, we need to split our applications between front end and back end. Okay, and that's something that you would have to do for most applications. Anything that has any level of complexity, generally you would split out the front-end user interface that your users look at and what happens in the back end in terms of the processing aspect of that application. So we always recommend designing your application so that it's decoupled, because your different ends, your front and your back ends, have different scaling requirements based on the type of processing that's happening in the back end compared to the requests that are coming in the front end. And so there's a couple of services that I want to talk to you about that are going to enable you to build your application with this decoupling in mind, which is really important when you're building solutions that are really scalable. Okay, so the first one is, before we actually look at, if we look at the scenario, we've got Menu here who is uploading his PDF document to the website, and the web application, what it's supposed to do is extract that data from the PDF document, okay, in some form of some format that it can understand and appreciate, and use that format to then build out the actual site for Menu, so that Menu can send the link to all of the recruiters and the hiring managers out there. Everything is happening on the same server within the same application stack. This is what we call a monolithic structure. And unfortunately, this has some drawbacks. So to illustrate the drawbacks, let's say you've got all of these users suddenly deciding to use your application, your website, your resume website creation application, because it's just an amazing website you've built, a web application you've built. They all send in their requests and they all send in their PDFs all at the same time. What's going to happen, because it takes a bit of time to extract the data and then create that website for each and every user, the backend is going to have a backlog. Okay, it's not going to be able to keep up with the requests that are coming in on the front end. This is an ideal scenario where you really want to decouple, you want to split the front end from the back end. And the way we do this is we use something called a queuing system. Okay, so when you think about, going to a supermarket, when you pick up all your products and you go to the tills and you go to the checkouts, if a lot of folks are coming in under the checkouts, right, there's a queue that's going to build up. And your checkout assistant is obviously going to take care of you one by one, scan your products in, tell you what it's costing you, you'll make the payment and end the transaction. So the backend process, the checkout process, is taking far longer than you picking up products and going to the tills itself, right? So in the same way, you want to decouple your front end from your backend services. And so here, we're going to split the web application so that the front end just presents the front end element of it, the UI, the ability to just look at all of the products, and the backend handles all of the transactions that take place. In the case of the resume website, therefore, our user is going to use, or our application is going to use something called an SQS queue, or a simple queue service. The way how it works is the requests that are coming in from the front end are going to go into the queue, and the back end is going to pull those requests when it has capacity to cope with it. So our friend Menu sends in his PDF document. A message will go from the front end to the queue, right? And it's going to sit in the queue. The actual PDF document could be sitting in an S3 bucket subsequently, waiting to be picked up. But there's a short message that's sitting in the queue that says, hey, there's a PDF document from this guy called Menu. Okay. And so then what's going to happen is when the backend has the ability and the capacity to cope with it, it's going to pull that message down, extract the data from the PDF, generate the website for Menio, and then hand over the website URL to Menio. So, excuse me, he can see his actual resume online. Okay, so this is what Amazon SQS is capable of doing, giving you the ability to split the front end from the back end and add a queuing system so that we can scale it both ends independently. So SQS is a queuing system, a message queuing system that you would build in your application stack in a lot of cases because you need to separate out front end from back end. Messages are stored in the queue. It's usually stored in the queue for a default of 4 days. You can extend that as well. Backend receives messages when it has capacity. So it literally pull the queue, see if there are any new messages, and then pull it across. Backend will then process the request and then go back to the queue if there's more work to be done. And the front end and backend can scale independently. So the backend will scale based on the number of messages in the queue. Maybe it needs more service. The front end will scale based on the number of requests that are coming in from the general public. And so hopefully you can see that building a solution is quite complex, okay? And you need to consider how you handle traffic and how you process that traffic so that your end users are not sitting there feeling like this site is just taking too long to respond to me. There's another service called the simple notification service. This is also used for decoupling architectures, but it also does something else. It sends out notifications to different services and resources based on your specific use case. So for example, we've got our good old Beancraft e-commerce website again, and our friend Menio is placing an order. So he goes to our S3 bucket, which is hosting the static website, and he browses his favorite coffee, adds to cart, does the checkout, and does the payment. When he does the payment, we could have a situation where that initiates a message or a notification to be sent out to, for instance, an email address. Okay, so we can send an email back to Manny and say, hey, your order has been placed. Shipment is going to follow and you'll be getting your coffee very soon. So Amazon SNS stands for Simple Notification Service, allows you to send push-based messaging out to different services. In this example, it's just sending an email back to Menio to tell Menio that your order has been placed. It does and has far more capabilities than that, however. So for instance, we've got this whole concept of a publisher and subscriber model. So in this case, the email is subscribed to that topic, and any payments that happen and are successful, notifications get sent out via email to the relevant customers that have placed the order. But in addition to that, notifications can be sent to any of those services: Lambda, SQS, HTTPS endpoint, and SMS text message. So if you get a text message, it might have come from an SNS topic. And it just enables you to therefore ensure that you have a decoupled architecture, but also add your notification elements to your application stack that you might need, depending on what the use case of your application is. So Amazon SNS is yet another service that you can use in order to define and build your application. And in fact, we will be using Amazon SNS on Friday, and you'll see exactly how it works in a real world use case scenario. Okay, so Amazon SNS is a notification system. It uses what's known as a publisher subscriber model. Notifications can be sent to various AWS services as well as email and SMS. Okay, very briefly, I want to also talk to you about how, sorry, give me a second, how this, sorry, a second, how this service actually works with event notifications. So you can use Amazon S3 event notifications feature to receive notifications when certain events happen in an S3 bucket. Now, this is a particularly useful feature of S3. I'm kind of taking you back to S3 as well, because I want to highlight exactly how Lambda functions can work, okay, based on the fact that Lambda functions are event-driven applications. So here's an example. You got an S3 bucket, and you configure it with event notification. An event can be anything. It can be the creation of an object. Okay, so when you add an object to an S3 bucket, that is an object create event. It can be an object remove. So when you delete a file from an S3 bucket, that's an object remove event. Object restore, object replication, lifecycle expiration, intelligent tiering. If you use intelligent tiering, any events that take place in there, those are all events that are taking place in your S3 bucket. And what you can do with that is actually use that to trigger certain actions, certain responses, certain processing of your overall application stack. So we've got our friend as well as an application. So anyone really, either a user or an application that uploads an object to an S3 bucket, in this case, say the resume, that could trigger an event notification, and the notification can be sent to different services. So it can be sent to a Lambda function so that a Lambda function can react to that event that just took place. It can be sent as an email. Someone just uploaded a file to the S3 bucket, or someone deleted a file from the S3 bucket, and it can be sent to an application to do some backend processing. I want to highlight the Lambda function here. Do you remember we spoke about Lovable over the last couple of days? You uploaded a PDF document to Lovable. Lovable then took that document and extracted the data and created the website. How did Lovable, or any other application for that matter, know what to do when you uploaded that PDF document? Usually, potentially, it might have been because of this thing called event notification. So user uploads the PDF document to S3. What happens then? How do we trigger the next step? We send out an event notification to a Lambda function to extract the data from the PDF document, or to trigger another service that could extract the data from the PDF document so that we can get hold of the raw data itself, right? So here, the event notification element or feature of S3 is paramount in building this entire application lifecycle and its end-to-end solution. I'm kind of hoping that you're beginning to see just how powerful Amazon S3 and all of these other services, when connected with each other, actually helps you build a complete end-to-end solution. Okay, so just to reiterate, user uploads their PDF to S3. Okay, great. But then something needs to happen. We need to tell the other service to extract that data from the PDF. We can use this event notification mechanism to trigger that Lambda function, so that the Lambda function knows, there is a new file there. I need to go in and actually do something with it. Okay, so event notification is a really cool feature that sends out notifications to AWS services to allow them to carry out their function behind the scenes. Okay, are there any questions? Any questions at all? Vinayak, you have a question on security perspective we have to enable or not? Absolutely. So when it comes to any of these services, there's definitely various different security components that you might need to consider. So remember, we've got different services talking to each other. We need to think about IAM roles, whether we're granting the correct set of permissions, otherwise it will just not work. You also have things like when you look at, SNS topic and SQS queues, what policies they have in order to allow other services to send them information. So for instance, in order for this SQS queue to actually respond to a trigger, to respond to an event notification, it needs to permit the S3 to talk to it. Okay, so there are some access policies as well that can be configured. When it comes to deploying solutions on your EC2 instances, as an application, you need to think about things like VPC security, the security group, the network access control list we talked about, HTTPS instead of HTTP, because you want to encrypt your users' traffic when they're connecting from the internet. CloudFront offering you the ability with web application firewall, the shield for DDoS protection. And so there's a vast array of security services that you would need to consider as you're building out your application stack. and incorporating them as well. And then there's things like monitoring and observability that you should also be considering when you're building your application on AWS so that you can track things, easily log issues and identify bugs and quickly fix them. So yes. Okay. All right, awesome. So I've got homework for you again. You've got the video that's going to be available on YouTube, and obviously you can use that video to just go through the exercises that we've just completed. It'll be so awesome if you can deploy an EC2 instance, deploy a web server using the script that's available in the GitHub repository, and publish the sample resume website as well so that you can see how it works in action and get some hands-on experience with that. Okay, so that'll be really cool if you can do that as well. We're pretty much coming to an end. If you've got any more questions, let me know. But otherwise, as usual, you can reach out to me on LinkedIn. You've got access to the YouTube channel for where you can see the recordings and also, the website if you would like to visit the website as well. Okay. Any questions at all before we end today's session? Okay. Well, if there are no questions, then thank you so much for taking the time to join us again today. And I hope you found this useful. Okay, sorry. Yep, sure. And I hope you found this useful. And tomorrow we're going to be moving on and taking a look at a quick introduction to AI services and AI technologies on the AWS platform. So do join us for that. And I hope to see you there. Thank you once again. Have a nice evening.